For centuries, science sought order. Newton's laws described a predictable universe. Planets moved like clockwork. Equations dictated reality. Then came chaos. Chaos theory whispers a different story. It speaks of interconnectedness, of systems far too complex to predict with certainty. A butterfly flaps its wings in Brazil and a storm brews in Texas. This is the essence of chaos. Tiny changes can cascade into massive consequences. It's a new way of seeing the universe, one where order and unpredictability dance in a delicate balance. Unraveling the threads of complexity. Chaos theory is a fascinating branch of mathematics and science that explores the behavior of dynamic systems that are highly sensitive to initial conditions. This sensitivity is often referred to as the butterfly effect, where small changes can lead to vastly different outcomes. Imagine a game of billiards. At first glance it seems straightforward. You strike the cue ball. It hits another, then another, each collision sending ripples of unpredictable motion across the table. The initial force you applied to the cue ball sets off a chain reaction, creating a complex web of interactions. This is a chaotic system. In nature, we see chaos in the swirling patterns of a turbulent river or the unpredictable movements of a stormy sea. Chaos theory doesn't mean things are random or meaningless. Instead, it reveals that within apparent randomness, there are underlying patterns and deterministic laws. It means even simple rules can create incredibly complex results. For example, the growth of a plant follows basic biological rules, yet the final form is intricate and unique. Tiny variations in starting conditions can lead to wildly different outcomes. This is famously illustrated by the butterfly effect, where the flap of a butterfly's wings could theoretically set off a chain of events leading to a tornado. This is why we can't predict the weather far in advance. The atmosphere is a prime example of a chaotic system, where small changes can have significant impacts. The atmosphere is a chaotic system. The interactions between air currents, temperature, and pressure create a dynamic and ever-changing environment. A slight change in temperature or pressure today can mean sunshine or a blizzard next week. This sensitivity to initial conditions makes long-term weather forecasting incredibly challenging, as even the smallest variables can lead to drastically different weather patterns. Imagine a butterfly flapping its wings in the Amazon rainforest. This seemingly insignificant action, a delicate flutter, might appear trivial at first glance. This tiny action seems insignificant. Yet, in the grand tapestry of nature, even the smallest movements can set off a cascade of events. But could it, through a chain of atmospheric events, eventually influence the formation of a hurricane thousands of miles away? This concept, known as the butterfly effect, suggests that minor changes in initial conditions can lead to vastly different outcomes. This is the essence of the butterfly effect, a powerful metaphor for chaos theory. It illustrates how interconnected and sensitive our world is, where a small action can ripple through time and space, creating significant impacts. It highlights the interconnectedness of systems and the sensitivity of outcomes to initial conditions. Just as roots of trees intertwine and streams merge to form rivers, our actions are part of a larger, intricate web. Even the smallest change can have profound and unpredictable consequences. A single pebble dropped in a pond creates ripples that extend far beyond the point of impact, illustrating how minor actions can lead to significant effects. This is true not just in weather patterns, but in ecosystems, financial markets, and even our own lives. Every decision we make, no matter how small, can set off a chain reaction, influencing outcomes in ways we might never foresee. From the flutter of a butterfly's wings to the choices we make daily, small changes indeed have the power to create big impacts. Chaos theory isn't just an abstract idea. It has revolutionized our understanding of fields as diverse as meteorology, ecology, and economics. Weather forecasting, once based on linear models, now incorporates chaos theory to improve accuracy. Ecologists use it to study population dynamics and the resilience of ecosystems. Even financial markets, with their complex interplay of human behavior and economic factors, exhibit chaotic patterns. Chaos theory helps us understand these fluctuations and manage risk. Section 5. Real-world chaos examples we can all understand. Imagine baking a cake. You gather all your ingredients, measure them precisely, and follow the recipe to the letter. You preheat your oven, mix your batter, and pour it into the pan. Everything seems perfect. Yet despite your meticulous efforts, one time the cake turns out perfectly golden, while another time it comes out slightly burnt around the edges. Why does this happen? Perhaps there was a small difference in the oven temperature that you didn't notice. Even a few degrees can make a significant difference in baking. Or maybe the humidity in the air was different. High humidity can affect how ingredients like flour and sugar interact, altering the final outcome. This is chaos theory in action. Everyday examples of chaos theory abound, showing how small changes can lead to vastly different results. Consider a traffic jam caused by a single car braking suddenly. One small action can ripple through the entire system, causing a massive delay. Or think about a rumor spreading rapidly through social media. One post can be shared and reshared, reaching thousands of people in a matter of minutes. The unpredictable path of a smoke plume is another example. Tiny changes in wind direction and speed can cause the smoke to twist and turn in unexpected ways. These examples highlight how small variations in initial conditions can lead to vastly different outcomes. This is the essence of chaos theory. Chaos theory isn't just an abstract concept, it's a principle that we can observe in our daily lives. From baking a cake to navigating traffic, from social media trends to the movement of smoke, chaos theory helps us understand the complexity and unpredictability of the world around us. It reminds us that even the smallest actions can have far-reaching consequences, shaping our experiences in ways we might never have anticipated. Section 6. Predicting the unpredictable. The limits of chaos. Theory. Chaos theory reveals the limits of prediction. While we can study patterns and identify potential outcomes, we can never know with absolute certainty what the future holds. This doesn't mean planning is futile. It means embracing flexibility, adapting to changing circumstances, and recognizing that even small decisions can have significant ripple effects. Chaos theory encourages us to be mindful of our actions and their potential consequences, fostering a sense of responsibility for the complex systems we inhabit. Section 7. Embracing the unknown, chaos and the beauty of complexity. Chaos theory challenges us to see the beauty in the unpredictable. It's a reminder that the universe is a dynamic, ever-changing tapestry of interconnected systems. Instead of fearing the unknown, chaos theory encourages us to embrace it, to find wonder in the intricate patterns, the unexpected connections, the sheer complexity of the world around us. Chaos reminds us that life is not a linear progression but a journey full of surprises, detours, and unexpected turns. Section 8. Chaos in nature, from weather patterns to animal populations. Nature is a master of chaos. Weather patterns with their swirling winds and unpredictable precipitation are a prime example. Animal populations fluctuate in response to changes in food supply, predator-prey relationships, and disease outbreaks. These fluctuations often exhibit chaotic dynamics. From the intricate branching of trees to the turbulent flow of rivers, chaos is woven into the very fabric of the natural world. Section 9. The human element, chaos in society and history. Human societies are complex systems too. The rise and fall of empires, the spread of ideas, even the stock market, all display chaotic behavior. Think of a revolution sparked by a single event, or a technological innovation that reshapes society. These are echoes of the butterfly effect, where small changes trigger massive consequences. Understanding the chaotic nature of human systems can help us navigate uncertainty, adapt to change, and build more resilient societies. Section 10. The legacy of chaos. A new perspective on the universe. Chaos theory is more than just equations and scientific models. It's a shift in perspective, a new way of seeing the world. It reminds us that the universe is not a machine, but a living, breathing entity, full of surprises and endless possibilities. Chaos invites us to embrace uncertainty, to find beauty in complexity, and to marvel at the interconnectedness of all things. Section 11. Conclusion. Finding order in the chaos. Chaos theory doesn't mean abandoning the search for knowledge. It means refining our understanding of how knowledge works. We can't predict everything, but we can study patterns, recognize trends, and make informed decisions even in the face of uncertainty. The universe is a tapestry woven from both order and chaos. By embracing both, we can better navigate the complexities of our world and appreciate the delicate balance that makes life, and the universe itself, so endlessly fascinating.